Okay, so last time we left off, we finished drawing our doors and tied those states to a certain bit within a byte, so we can toggle them on and off, and we'll draw or not draw a certain door. But we still have no collision associated with these doors to actually make them into a barrier. So let's account for the collision. So every time we draw a door, we're going to update the collision. So let's do that inside of the draw door functions. So draw top door, draw left door, draw right door. And those are stored down here. So every time we draw the top door, we also jump to subroutine and we'll say set top door collision. And we will do this for all of the doors. So we're going to have a set top, set left, set right, and set bottom door collision. All right, now what happens in these functions? Let's go ahead and write them. So set, let's worry about the left-hand one for now because it's going to be easier. So set left door collision. So what do we have to have happen? We're going to load a value that's going to contain collision bits, and then we're going to write it into the collision map that is stored in RAM. So let's actually look at this bitmap here. This is the lobby, so there's a top door, a left door, a bottom door, and a right door. And by default, it loads into an open state, as in the player can walk through it. So we need to target, for the left door, these specific bits over here, and we want to change this value from 110000 to a 111000. So I'm just going to copy paste this 11000, and that should be F0 in hexadecimal. We'll stay with the binary just because it's representative. And let me put this as a comment over here. Oh, actually, I can just put it here where I put the load A. So load A, numerical binary value, this. This is our closed left door. Okay, now how do we figure out what byte we're actually going to write to? Now, we know the formula for this already. So it was x, the x-axis plus y times the width of the two-dimensional plane. So these bytes are in the 0 axis on the x. So we substitute x for 0. And then let's count how many down in the y direction they are. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, 14 and 15. So let's put in, let's go to calculator. Counting in decimal, 14 times 4 is 56. So we have 56. And then just to be sure, 15 times 4 is 60. So those are the byte positions we're going to alter if we're altering a left-hand door. And those both get set to this same value. So let's kind of write that. We have all the pieces we need. So we load the value that would designate a closed door. We store it in collision RAM index. Oh, no, we can just put a plus offset. Plus, what was it, 56 and 60? Yeah, 56 and 60. So collision RAM plus 56, store A, collision RAM plus 60, and return from subroutine. I'm trying to think of a way to actually test this. So I'm just going to create an arbitrary loading zone that removes this door. No, we actually don't need to, because when you draw the door, it draws collision, so it should work. I don't know what else. I was thinking way ahead, thinking in terms of removing doors. Let's actually render this. Unknown label, so 745, 755. That's probably our jump to subroutine, set bottom, set top, blah, blah, blah. Let's comment those out. Those don't exist yet. unknown label 745. 745. Set top door collision. We didn't. Oh, so yeah, we're not doing the top one. We're doing the left. So let's uncomment the left door. Silly me. All right. Okay, so this should now have collision, hopefully. Bam! Ran right into it. Now these right-hand doors and the top doors still don't have collision because we need to do the same thing. So let's do the top. Bam. We'll put this down here. Oh, and let me make sure my order is in the way I like it. Top, bottom, left, right. And what are the values and where are these stored? So top, it's going to have two different byte values because it kind of ends up being on a seam of these 2 bytes. But they are going to be closed and it's going to create all ones. So it's technically just going to be FF, so all ones. And then there's 4 different byte locations instead of the 2 that were on the left-hand door. So let's just load FF. And that's the same as all ones. And then we're going to store in those byte locations, which we can figure out. So this is going to be X0, 1, 2, 3, and 4. So Y3, Y4, and then X2 and X3. So let's say X is 2 plus 3 times 4. Three times 4 plus 2 is 14. And then we have 2 plus 4 times 4. So 4 times 4 is 16, plus 2 is 18. And then we have the x equals 1. We just did this hand side over here, so x equals 2. And then x equals 1 plus 3 times 4. And then 1 plus 4 times 4. So we got 3 times 4 plus 1, 13. Then we have 4 times 4 is 16 plus 1, 17. So these are all those offsets. So it looks like 13, 14, 17, 18. So let's go collision RAM plus. Let's highlight this, copy it 3 more times. Yeah. So what did we have? We had 13, 14, 17, 18. Was that right? Yeah, 13, 14, 17, 18. So this should take care of collision on the top door. Let's see if this is true. No errors. Head straight for the top door, and bam, collision. All right, let's do the same for the rest. So top, bottom. And let's see what the bottom ones are going to contain. I think the value is also going to be FF. Yeah, because it's still on the same seam, and it's just going to render all ones. We just have to find those indexes. So we're again going to load the value of FF. I'm going to store in collision RAM plus some offset, and there's 4 bytes in total. So now we just need to find those offsets. So this is, again, x1 and x2, still times 4, but then these values are going to change. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and 26. So we have 25, 26, 25, 26. I'm just going to double check that. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 25, 26. Okay, those are correct. So now let's plug and play. So 25 times 4 equals 100. 25 times 4 equals 100. 100 plus 1 is 101. 100 plus 2, 102. 26 times 4, 104. 104. 104 plus 2 is 106. 104 plus 1, 105. So 101, 102, 105, 106. 101, 102, 105, 106. Render and test. No errors. Head straight for the door. Oh, and we walked through it because we actually want to test the bottom door. Oh, we didn't return from subroutine. There's going to be glitches because of that. Save. Let's try this one more time. Bottom door. And that wasn't right. So I'm wondering... Oh, we didn't comment out the bottom door. So it's in a comment right now. And it's not going to run if it's commented out. Bam! Collision. Awesome. Now just this this right-hand door and we'll be done. I'm going to uncomment it out right away. And then we're going to set right collision. Now, what are those values? It's going to be similar to that first one where there's going to be some that are zeros and some that are ones. So it's going to be these bytes, and we'll basically be toggling these bits on. So 4 zeros and 4 ones. So we're going to load binary number, 4 zeros, 4 ones. I'm going to store that in collision RAM plus some offset, and we only need to do that twice for the right door. And then return from subroutine. And let's find those indexes, or indices. So it's going to be x0, 1, 2, 3, 3, 3. We're only going to need 2 of these. Then we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, and that's the same as before. So 14, 15 times 4 times 4. Good old calculator. 14 times 4, 56 plus 3, 59. 15 times 4 plus 3 equals 63. 59, 63. Offset 59 and 63. Saving those, render, check for errors, and test. Right hand door, bam, collision. Top hand door, collision. Left, bam, collision. Bottom, bam, collision. Awesome. So every time you draw a door, it's going to alter the collision, and every time you move to a different room, it's going to just load the default collision, which it defaults to being open. So anytime a door is drawn, it's going to take care of collision in the background, and anytime one is not drawn, it's just going to be free for the player to move in between. Now we just need some sort of mechanism that the player can actually unlock these doors. So we'll add like a little inventory, we'll give them a little key, which will basically be just a bit that you toggle on and off, just like kind of the rest of this stuff was. And if he's in possession of the key, we'll write the functions to then remove the door and remove the collision. See you in another episode.